Hello friends. So this problem is about breaking of a object from a surface. So here I have two blocks, block A and block B, and these two are having same mass m. And block A is attached to a spring and natural length of a spring is given, this is L naught. And block A is also attached through a string to block B, which passes over a pulley. Block A is further connected through a string to the wall. What we do is basically we cut this thread and then this system will starts moving in the downward direction. We have to find the velocity of block A and block B when block A just lifts off the plane. So let us try to read this problem. So it says figure shows a body A resting on a smooth horizontal plane attached to a bait B of same mass. Body A is attached to the fixed support O by an ideal spring in its natural length L naught and force constant K 5 mg by L naught. If a string S is cut, find the speed of masses A and B when A will break off the plane. So let us try to see what will happen once you cut this thread. This system will start moving. So this block will start moving in the downward direction, this block will start moving in this direction, and at certain point of time, let's say this block A has come to this position. So this has moved to this position. Then a string, basically a spring here in this case, so a spring will be elongated. So a spring will be something like this. Now what are the forces that is acting on this block? So on this block, one force is acting in the downward direction, mg. Another force is normal reaction that will act in the upward direction. Now what is the length of a spring this time? So this length is L naught. So this total length will be L naught divided by cos theta. So let's say this angle is theta. So this length will be L naught divided by cos theta and this length will be L naught tan theta. So this length will be how much? L naught tan theta. So what is the elongation in the spring? Natural length was L naught and at this point of time length is L naught by cos theta. So we can say at this time elongation in the spring this is equals to L naught divided by cos theta minus L naught. So let's call this as x. So you can basically say there is a force that will act on this block due to this spring in this direction. And this force will be k times x. And this angle is theta. So component of this force will come in this direction and this component will be kx cos theta. And in this side we will have kx sin theta. Now question says block A is just going to leave off the plane. So this block is just going to leave off the plane. This means at the time of leaving off, we can say normal reaction is equals to 0. So let us write equation of motion in the vertical direction. For block A, in the vertical direction, forces are normal reaction plus kx cos theta minus mg. There is no other forces that is acting and there is no motion in the vertical direction, so we can say this is equals to 0. But normal reaction is also 0, so we can say kx cos theta is equals to mg. And the value of k is given, that is 5 mg by L naught. So let us plug this value 5 mg by L naught and x is nothing but L naught divided by cos theta minus L naught, and this is equals to mg. So from here I can solve for cos theta. So this we can write mg gets cancelled out and L naught also gets cancelled out. So we will have this thing. So from here we can write this is 1 by cos theta minus 1 is equals to 1 by 5, or 1 by cos theta is equals to, basically I missed one theta, cos theta here. So this cos theta will also be there. So this times cos theta is equals to mg. So now I can rewrite. So let us rub this part. So we can have into cos theta is equals to 1. So we can have 5 1 minus cos theta is equals to 1. So from here I can write cos theta is equals to basically 4y5. So now I know the cos theta. So at this point of time the block is going to just leave up the plane. Now we have to find what is the velocity by which this block is going in the downward direction. Now see, this block and this block A and B will have same velocity because this is attached to this string. So this is attached to this string. This means both will have same velocity. So we can say in this case mass A and mass B both will have same velocity. Let's say this velocity is V naught. So now we can apply energy conservation. So let us say apply energy conservation. So you can pause the video and you can write energy conservation equation and you can solve for V. Okay, so I hope you have solved this equation. Then what are the energy? So you can use loss in potential energy. So why this is velocity? Because this mass has moved to some distance, because this will A has moved, so B will also move and it will come up to this point of position, at this position. So it has moved to this position. So there is a basically loss in potential energy. And how much this distance? So this has moved by distance of L naught tan theta. So this has also moved by a distance of L naught tan theta. So basically there is a loss in potential energy. So we can say loss in potential energy is equals to mg L naught tan theta. And this loss in potential energy has basically gone into change in the kinetic energy, and some part has gone into potential energy of a spring. So let us say loss in potential energy is equals to gain in kinetic energy half mv square for one block and half mv square plus another block, plus some part of this loss has gone to the potential energy of a spring. So what is the potential energy of a spring? Half kx square. So some part has gone into potential energy of a spring, that is half kx square. So let us rewrite. We can write mg L naught, and tan theta is nothing but 3 by 4 because cos theta is 4 by 5, plus half mb square plus half mb square is mb square, plus half k value is given, that is 5 mg by L naught. And x is how much? X is nothing but, if you remember, x is L naught minus L naught cos theta, and cos theta is 4 by 5. So L naught this distance, the x was L naught divided by cos theta minus L naught, and cos theta is nothing but 4 by 5. So we can write this becomes, so this becomes mg L naught 3 by 4, and this will be mv square plus half 5 mg by L naught, and this is basically kx square. You see this is kx square. So this will become 1 by 4 and whole square of that. So 1 by 16 L naught square. So let us cancel term m. So we can cancel m gets cancelled out. So we will have GL naught. So 3 by 4 GL naught is equals to, and this is V square, and this will be 5 by 32. 5 by 32 ZL naught. So if this goes this side, I can say V square is 3 by 4 minus 5 by 32, and I can take ZL naught common. So we will have 32 and 24 minus 5 ZL naught. So basically I can write V square is 19 by 32 ZL naught. So from here I can say velocity is equals to a square root 19 by 32 ZL naught. So this will be the velocity with which both block will be moving. Now question for you. So in this problem we have assumed there is no friction on the horizontal plane, that is mu is equals to 0. Now what will happen if there is a friction? So mu value, let's say, is given 0.5. Now where the changes will occur in the energy equation? Will both block will have same velocity? Will they have different velocity? So let us discuss all this in the comment box, and I will see you in the next video. I hope you enjoyed the video. If you enjoy, please share with your friends and subscribe to my channel. Thank you.